So my project is pretty simple. Well, in theory at least. What I'm trying to do is understand how a diving board works, because according to my coach, anything that just falls on a diving board will carry out away from the diving board so you don't have to worry about landing on it. However, I don't necessarily believe him, so I want to find out why this is true, or whether or not it even is true. The only explanation that comes to mind for me of why an object might be carried away from the board when it is dropped is that it must leave the board below horizontal, which means that its tangential velocity is going to carry it outward because it has an x component as well as a y component. This x component would then carry the object away from the board in theory, and this is what I need to prove in my series of experiments. The first thing I did was drop an orange, and the first thing I noticed was that the orange rolled on the board. First I thought this was silly, but then I realized that it makes sense once I started to think about it. This is because the orange is continually acted upon by gravity, which tries to push it down. And at the bottom of its ride on the board, it can no longer just go through the board, so it tries to move in the x direction as well. And since the coefficient of static or friction is too large that it can't just slide, this makes the orange roll. The next thing that I noticed was that my hypothesis about the object leaving the board below horizontal was wrong, because, at least in these examples, the orange appeared to separate from the board not just at horizontal, but above horizontal. This would mean that, according to my hypothesis, the orange should actually travel backwards back into the board. But that's not what happened, so either I need to rethink my hypothesis or come up with a mechanism for why the orange, it did in fact separate below and not above. One possible theory for why the orange might have actually separated with below was because it's a pliable object. This means that it actually squishes when it reaches the board, and then when it's leaving the board again, it's actually taking time to reinflate to its real size of what it should be, so its contacts at the last moment are not actually important and don't mean anything. So I can't actually see the moment of separation that is important for what I need for my tangential velocity experiment. So that means I'll have to rely on objects that aren't as pliable as an orange. Next, I dropped a tennis ball on the board. This reacted much the same way as the orange did. It rolled in a much more uniform fashion because it's perfectly round, except instead of deformed slightly, and it also left the board above horizontal as well, which does make sense because the tennis ball does deform as well and then have to spring back to its original shape, which could account for that fact. This means that I'll have to rely on other objects to explain any other meaning I need to find. The next object was a weight, a small one and a large one, which both behave the same way, so I'm just going to treat them as one object. Unlike the balls, they were not round, so they could not roll, but this just meant that they slid off the end when they got to the bottom of the ride, because gravity was trying to keep them keep moving downward. One disappointment for me was that the weight is not a compressible object, so it cannot. Its last point of contact is its last point of contact, no doubt about it, and it too departed above horizontal, so I will have to think about another mechanism for that. So these are all the experiments I run and all of the data that I collected. So that means that I need to find another way to explain why objects that are dropped on the board are carried out from the board, because it was not the tangential velocity as I thought it was. One thing that I did find interesting was the rolling or sliding exhibited by the objects, because obviously this does not happen for humans. But on a real board, the board is aerated, so it has a greater coefficient of friction. So what I am wondering is whether or not there's anything that a diver does to compensate for this forward movement that they feel that they might experience, and how this complicates the model I will have to make for future references.